So I bought one, programmed them all, put the old one back on top, and then
Okay.
if I have any trouble, I take the good one out of
Take
the
the good one
office.
out of the office and put, okay.
Yeah,
I've not heard of that though, that's interesting, lighting, I mean, golly. Well, it does have electronics in it.
What about power failure? Is that power failure protection?
That's a good question, I mean, it doesn't, not per se, but it,
It just let this drop.
but it's only, I mean, it's supposed to be getting a regulated power from it's 24 volts DC.
Lightning can do anything.
It's 24 volts
I
DC.
agree.
No, I know it can. This is just uncommon. I'm not hearing, this is the first time I'm actually hearing this, to be
I
honest.
don't remember how much it was, but I had 5 of them at once needed replaced.
Wow. There must be more to that than I don't know.
So battery backup, something else is.
So what's supposed to happen is, well, it's got a range that it can operate with. It's like the IK motor, it's 24 volts DC, so it's not the same. I think that's the one I was getting confused, I think, on the level sensor, I believe that's the one that's 14 to something, 14 to 30 that it needs to be. I'm almost positive that's what, and then the AC component of the DC, can't be any more than 5 volts. So what I'm getting at is, it needs to be a regulated supply DC, that's very precise, I guess is what I'm trying to say, with its AC component. And what we find a lot of times is if the supply in the building or in the area, the voltage is not good and it's unclean, then what's going to the level sensor is not gonna be good as well. It's just gonna reflect to it. So what people end up doing is isolating that with an isolated power supply of some sort, because it needs to see a clean, it needs to see a clean DC signal. I don't know. I'm wondering if that may have something to do with what happens. I don't know. I'm not aware of it, hearing that though. Actually, it's interesting. Okay, so here it is, AKS 4100. Just a lot of you guys haven't had any exposure to it, so maybe it's just good to know what it is. This is what it looks like. There's a lot of this that doesn't apply, so I'm going to glaze over it. Honestly, there's two different types: the cable on the left and the coax on the right. The cable is the most common for ammonia systems. The only place in an ammonia system you wouldn't use the cable is if you had that directly in an open tank. We would not recommend that cable. You would want to put the coax around that cable. And the coax version is nothing more than the cable with a coax tube around it, okay, and the cable tied down at the bottom with an end connector with some tension in it, okay? The cable, though, version is just free floating, but it has to be in a column or a standpipe, a measuring column or a standpipe. It has it's pretty much plug and play. There's no on-site calibration needed. The cable version is not affected by oil in that tube. So when the oil's in there, it still reads, and when the oil's gone, it still reads. You don't have to clean the oil off. The old level capacitive rods were really notorious for getting oil on them, and then they get soaked and they won't read. You have to pull them out and clean them, and this basically avoids that. The electronic head is replaceable while the system's in working under pressure. You'll see that here in a minute. It's compact. The cable version doesn't need top-end clearance, whereas the coax version does. The other place we recommend coax is in marine vessels and CO2. Those are the two where we require.
Do these have standalone controllers? I may be jumping the gun here, but
This particular one, we have a standalone controller, but it's typically, the signal is going to a PLC in most factories that I go into.
I just wondered, like it had standalone control, it had maybe 2 or 3 outputs on it.
For alarms and stuff, or?
Just for anything,
Yeah,
level
yeah, they're
control, anything.
Yeah, exactly, and digital outputs, you're gonna glaze over that one too.
All right, sorry.
No, it's fine, yeah, that's our EKE 347. The most common thing though that we see is a PLC. Just because plants typically already have a PLC system that's doing everything, so they just,
There's still a lot
Yeah.
out there that don't.
yeah. But what you can do is you can use our controller, and then you can output that to a Modbus to a PLC. That's what a lot of people do, because then if they have a PLC problem, now they got a backup for that level sensor with our controller.
Right.
I see that done actually quite a bit. Oh, and the cable basically comes 196 inches, so you can cut it down to like 31.5 inches is the shortest we have today. And there's a coax version that's shorter than that, but it has to be coax. So this uses TDR, it's guided wave radar technology called domain reflectometry. So the idea is this thing's pulsing about 1 million pulses per second down to the level surface. And simply put, the calculations are done in the level sensor itself. So it knows the speed of light. It can measure the time that it takes to make that transition, and so then we can get the distance from that can be calculated. So that's how it gets it. Here's an example of what it looks like. So this is the level sensor, that's the process connector, and the cable. So this is installed, this is inserting in there, so that's why we say you can actually remove this under pressure while it's operating. Yeah, there's just a connector there. Here's what the LCD display unit looks like. I'm not going to go into everything here, but it's very selectable and programmable. So you can have it name something. The units can be selected and how you want it to measure the level. Is it distance? Is it level? Is it output of the milliamp? Is it a percentage of the level, 50%, 100%, 25%, whatever you want? So that's fully selectable. What else here? And you've got the keypad on the front, so these all mean, you know, the menu, enter, right arrow, up and down, and it's a little, if you've never done one, it's gonna take you a little bit to do it, but we make the password really very simple. So when you first go into the supervisor and try to go to the next menu item, it's the first thing it's gonna do is ask you for a password. The password is press that button, that button, that button, that button, and go back here, there, and that's it. So it's through, and then the first two again.
Johnny could have found that out.
That's right.
Button pushing.
Yeah. Over here, just so you know, there's a hex screw that holds the cover on. The cover is either going to be a blank cover or it's going to be the HMI display cover. So once you program this thing, you have the option of just putting a blank cover on there, and then and I see people that do that, and then nobody can mess with it. But you've got your display, so you can change it out. There's just a little cable connector in there with some pins on it. And you can put it back on if you need to check something or program it, but then you put the blank cover on. That's particularly good if you got this thing outdoors. LCDs don't like I got a call from Wisconsin, Minnesota, I think it was. A guy was in his truck, he was warming himself up, and it's below minus 40, and the display quit working. I'm like, yeah, it's gonna quit working, but I said it didn't break it. I said if you warm it up, and then when it warms up, you can go back out there and put it back on, and it'll read. Yeah, it did.
Most of mine are outdoors.
Yours are outdoors, okay. The thing we don't do is we don't make a cover for it.
You cover like that motor's got on.
Yeah, we don't make a cover for it. And usually what I get response I get for that is go get you a PVC cap or something and put on there.
I've got
I don't know.
the automatic greasers for my condensers have these little socks that go over them.
Mm-hmm.
I've got those over them.
Oh, you do?
Yeah.
Nice. Yeah, that's perfect. I like that. That's nice. So,
Condenser's got what on it?
So,
Socks?
Automatic greasers they have a little sock that comes with them every time you replace the little
automatic
greaser in
greaser.
it.
so those
The
socks
little
actually
grease
fit
pack.
over our level sensor top.
It's just a little,
Yeah,
like a little fabric bag, right?
yeah, it's a plastic.
Oh, is it?
Yeah.
So you know, it's something that I've suggested, but usually what I get back is, you know, well, just have them put the cover on and then keep a separate display. But that might be inconvenient in some cases, but again, we're talking in a different country and we all don't have the same ideas, so. That's a 2.5 millimeter hex, just in case, if you wanna know, so you take that off. You probably already know that. We're not gonna talk about the coax really, there's no need, but the cable version, in the majority of applications, you've got a probe length and it needs to be between 31.5 and 197. Okay, you're gonna ask, well, what happens if I go outside that? I can't guarantee anything. If you go below 31.5 with the cable, Danfoss honestly just cannot guarantee that it probably might work, but it could be that it won't work. And definitely going above 197 inches, we don't know. We've heard of people actually putting, there's a kit you can buy that actually extends the cable length. And I've heard of a guy going almost to, what was it he told me? I mean, I can't imagine a tank with this level, but it was almost 250 inches, I think, or 300. And he did it, and it's working, and he's proud of it. But, you know, I told Danfoss, you know, factory and the designers, and they're like, man, and I'm like, well, the guy did it. You gotta salute him, you know.
How do the things work, their level probes, right? How do them work? So we have some issues with, some of our water tanks, things, but they get like foam in them. Usually those ultrasonics don't like those foam, that foam. How do
Right.
you handle that?
It's that time domain reflectrometry.
doesn't like
It's not
that.
effective. It can be gas. It can be
Really?
yes. And we don't sell it as water, but it will read water level. Yes, it will. I say that. I'm not gonna tell you no, like the factory wants me to say, because I know for a fact that people have done it. Why would you want to do it? I don't know, but you know, we sell it for refrigerant levels. But yeah, it's not. Because the oil doesn't affect it, nothing, it can read both gas and liquid, it does not matter. If there's gas in there, it's not gonna read the gas, it's gonna read the liquid level. And it's very reliable. The only thing about these, I will say, in my years of working with this AKS 4100, it's very much like the installation sensitivity of this thing. You do it right, it'll probably work every time. You follow it, and you just detail. AKS 4100 is just like that. It's like everything has to line up. The standpipe or the column
So it's conditional. It's gotta
has to
have
be
the right
uniform. Yeah. When we say install this way, set up. Well, we'll get into some more stuff here in a minute. But yeah, it's very particular. You do one little thing wrong and it may not work. The cable's not for use for CO2 or marine. But it's used for ammonia, HCFCs and HFCs and other liquids, as I've found it works. One important thing here is I'll just point out, since 2014, we have an extra piece on this thing. You can see in this picture. It's called a seal adapter. You can't miss it. It just interfaces between that and the process connector, and I've got a better picture of it. That has to be there. It's got a hex screw that's sealed, so you don't want to remove it. What that's doing is that process connection could leak a very, very small amount of ammonia out, and if you don't have that seal adapter, it's going to go right into those electronics. And it doesn't. Those electronics do not like the ammonia vapor. It will kill it every time. So that's why we have that there. So don't remove that. I thought I had another picture of it. I'll have to look see. This is coax, so we're not going to cover that. So installation, you can see here. Okay, so not in the tank, in the column, in the standpipe. Coax in the tank. Now you say, well, on the one there, A in the right, you've got the coax in a column. Why do you have that? Well, you can do that. We typically recommend that when people have called multiple times saying, I've got it in a column, everything I do, I program it, everything I do, this thing will not read right. And 9 times out of 10, they put that coax in there and it works. Our theory is they've got some kind of strange irregularity or something in the column that's just not right. And it's not always just that exaggerated, it's like there's a sight glass screwed into it and it's protruding into the column, just, the radar doesn't like that. It doesn't wanna see, wants to see a smooth, if you got a 3-inch column, it wants to see 3 inches going all the way down and all the way back up. It's just the sensitivity
Do
of
you
it.
think the bullseyes mess them up sometimes?
Yeah, and I see them on some, yeah, they've just got a multitude of them in there. I mean, it's like almost overkill.
Yeah, they're usually kind of consistent, but as,
Yeah.
and you can't overkill that, I mean, any time you see.
Well,
those-
yeah, but I'm literally, I've seen them where they're all,
Yeah.
all the way up and down. It's like, I was thinking, well, a couple of them would probably be good. But, yeah, so that's something to watch out for. There's your seal adapter, okay? So you can see that it's got, okay, so let's go over this. So, because this is gonna be important. So now that the seal adapter's there, that's gonna prevent the ammonia from coming up. And even if it comes up, it's gonna block it, okay? So what you're gonna do when you install this, so now you've got your process connector and your cable. It's it's a 3/4 inch pipe, so it's screwed in and it's in the system. Now you're gonna install what we call the head of the AKS 4100. What you're gonna do is you're gonna remove this top screw right here, and that's right here in the seal adapter. You can see it, okay? The reason for that is air gets trapped in that cavity because it's very tight. And when you put that head down on there on the process connector, you're gonna think it's going all the way down and engaging that coax connector. But you can see in the picture there, it's very important that makes good contact. So you take that screw out, it'll go down, make good connection, then tighten everything up. If you don't do that, there is a good chance that this thing will not read right. I've actually done it myself in the office with a little rig that we have. I literally left the air screw in. I tried to put it on. I pushed down as hard as I could. I tightened the screw. I couldn't get that thing to read. To save its life, I unscrewed the little air thing and the thing went. I tightened it back up and away we went. So it's something that happens out there. You got to be aware of it. Then tighten everything back up. It's 5 millimeter hex for those two. Did that make sense? Sort of, yeah. It's a tiny little thing, but it means, yeah, it can mean the difference between working and not working. So the cable version, here's the installation. You can see the counterweight. That just keeps the cable in the column centered and tight. Not tension, but just pulling down on it a little bit. And it will work, it should. There is a sticker on this thing, so the guy that installs it, hopefully he fills that out. 9 times out of 10 they don't. But the reason that is done, because you might have to reprogram this thing someday. You might call us and say it's not working. First thing we're gonna tell you is to go to factory reset. And when you go to factory reset, you gotta go back and reprogram it. And then the next thing you're gonna ask is, well, how do I know what I gotta put in? Because that's all set up at installation. That's the information's not there, you're really kind of screwed. So keep that in mind. That is probe type, so it's either cable or coax. Probe length, that's the overall length of the cable. The probe when the guy created it. The 4 milliamp 0% distance, okay? That's gonna be the largest number, not the smallest. That's gonna be the largest number. That's this value right here, okay? So at 4 milliamps, it's at 0%, but that's gonna be the longest distance. That's key because people reverse that. So if you reverse that and you call me up, what are you gonna be telling me? You're probably gonna be telling me, hey man, it's saying my tank is full, but it's empty. Or hey man, it's saying my tank is empty, but it's full. It's just gonna be flip-flop. We get that actually a lot. Then the 20 milliamp, 100%, that's gonna be your short distance up here, okay? What's the other distances then there that makes up the rest of the probe length? It's called deadband. There's always a deadband with this thing, and it's fixed, but you can increase it based on your setup, but you never decrease it. It defaults at the top to a number, and the bottom dead zone defaults. You can increase it, but it's got to be that number. That's just something that you need to be aware of and know. That deadband is important because that's where this thing's not gonna measure. Coax, we don't need to talk about that. You can see it's pretty straightforward. Screwing the tubes together, cable, tension. I did actually do that in the shop one day when I was actually in Baltimore. I just decided, okay. And so I did it, I just pulled on it with my hand. And I tightened the set screw up and I put it in the water. Thing wouldn't read, it would not read. Pulled it back out, put in a rig where I could pull on it with about 25 pounds. It says 100 newtons. And then I got somebody to help me. We tightened up the set screw, put it in, and perfect, it read. So tension in the cable, it's important on coax. Installation of coax, it's similar, but it's a little different. So here's the standalone controller, EKE 347 level controller. It's not terribly common, but it's available. It's what people tend to use as backup. PLC is probably the most common. So what's going to happen is you're going to supply, there's 2 wires on the AKS 4100, plus and minus for analog, and you're going to supply that with a 14 to 30 volt DC supply, and that's going to create a current loop. And that current's going to vary between 4 and 20 milliamps depending on what the level is the cable sees of the liquid in the car. It's that simple. If it's 4 milliamps, it's all the way at the bottom. If it's 20 milliamps, it's all the way at the top. Does that make sense? And that's why the PLC is really, it's probably the most common.
Well, just Hanson's had that one for a long time, it's got standalone.
Got standalone, yeah.
I've used it a ton.
I know, yeah, I know exactly what you're talking about, so. We're gonna talk about this, I think separately in another, so I'm not gonna do this one. So programming, okay, there's a lot of programming, but it's like everything. There's a basic quick setup that'll get this thing running. That's why we say out of the box, no calibration. It's almost a plug and play go, guys. It really is. So you're gonna go in to the menu. You're gonna enter quick setup immediately, or you could do the password and go into the supervisor. But the quick setup's gonna come up the first time you power it up, and you're gonna tell it it's a cable. You're gonna tell it what's my probe length. You're gonna tell it the length of the 20 milliamp or the 100%, so that's gonna be the short distance. And it's gonna be 4.7 inches if you think about it, that's your dead zone, dead band, but it could be larger. In your case, it could be larger, it just depends on your configuration. Then there's one I didn't talk about. With time domain radar, there's a thing called dielectric constant of the fluid, the refrigerant. Epsilon, that's a key to the reading of this thing properly. So it defaults, I think, to 1.066 for ammonia, and it works pretty good. But if it's CO2, it has to be adjusted appropriately or it won't work. So that's what it's saying here. But generally, you leave the dielectric constant alone. Okay? So we got the length at 4 milliamps, the length at 20, the dielectric, and you're done. And then it'll basically go into, there'll be a little light up in the upper right-hand corner that's saying that it's working, okay, or not. So, and in the menu there, after you do the quick setup, it's going to go to give you the main menu and a switch. It's called the main switch, and it's something that's overlooked quite often, but it takes you right there after the quick setup. You turn that on. It's just like our controllers. You turn it on, it starts doing level. If you don't, the level sensor will not read. So again, I get that. I know it's just one of those things. I get that call a lot. And it's like, go into the main menu, look under reference. It's going to say main switch. Turn the main switch on. Oh yeah, it started reading the level now. Okay, I think we do that just to. No, I don't know why. There's a reason for it, but it buffaloes people a lot.
I think it's the most user-friendly Danfoss controller that we have in the plant. We have everything that you've went through so far.
Excellent, well, that's good. Yeah, unless you have unless you have an installation issue and a problem, I think quick setup does it and you're gonna be fine. And I'd say 99% of the time, It works great. I do get them though. I've got one right now in, I wanna say it's in either, I think it's in the Virgin Islands somewhere, or Bahamas. He's got 6 of them, and we've been going around in circles for literally for months. It's unfortunate, you know. No, I'm just saying.
I'd wanna fly down there and check it
Yeah,
out.
you might, yeah, take up.
Yeah.
I'd go with you.
Yeah.
He's read this manual hell.
Yeah.
Yeah. Unfortunately, I can't pay you to go down there, sorry. Well, anyway, this guy's gone, you know, he's gone through, displays, you know, it's just been one thing after another. He keeps killing displays, and I'm not sure how he's doing it. He's
You can go figure it out, I'm telling you.
yeah, oh, I know, I guarantee you, but, okay.
Probably take a week.
So, yeah, there you go. Dead zones. Yeah, I'd go down there in a heartbeat if I could, but, yeah, I take direction from my boss. So let's see here. Yeah, there's the dielectric constant defaults to 1.066. Dead zones, those are the dead zones. That's what it's going to default to, but you can change that number. It won't let you decrease it, but it'll let you put in a larger than that default. What am I missing there? Yeah, if the refrigerant and temperature are precisely known, you can tweak the dielectric constant, but with ammonia, it's not worth the trouble. You know, I guarantee you, it's not going to be worth the trouble. So, and then dead zones for coaxial is a little different, so we won't go into that. Programming dielectric constants, again, that's pretty straightforward. I just use a default. And here's an interesting example. So the AKS 4100 is going to detect ammonia level, okay? And if there's vapor, you know, gas in there, it's not going to be affected by it. It reads again, it's, you know, down, it's up again. You know, and during the transients, basically this thing fills up with oil, okay? And, you know, once the oil is removed, you don't have to remove the AKS 4100 for cleaning. It's just not.
But if it actually fills up with oil, it will read the oil level, right?
Mhm.
Just any kind of fluid.
Yeah. But the key is in other systems, when the oil's gone,
You've got that slime on.
you got a problem, because if it's a capacity rod, it's not gonna read, no oil's gonna be on there. So what we're saying here is it just doesn't matter.
So the oil change dielectric constant?
A little
It's
bit.
different.
Yeah, it's different, it's different. So your reading with
Could you
oil,
change-
your reading with oil is not gonna be accurate, but it's gonna read. But why are you gonna wanna do that? You know, why are you gonna wanna do that?
Could a guy change, say, you know, that way, you know, you know your oil levels about where your money is at. The guy changed that dielectric constant of the oil to be reading the oil.
Yeah, it would
And then
fluctuate
you-
the reading, but I don't know if you'd really wanna do that.
Well, I mean, I don't think it would.
Yeah, I don't think it would, but honestly, yeah, that would be a possibility. Yeah,
I'm
'cause
sure you would.
it affects the reading,
I'd
definitely.
probably just drain the oil.
I think it's drain the oil, I get the oil out of it.
I'm just saying.
The point is that I hear people talk about it, and it's been years ago, but having to clean those things is really a hassle,
That's why I would
Because,
do that.
you know, you can't read your level, and you're just like, okay, I only got one choice here, I gotta pull the rod out and clean it. So, and we don't have that, so it's pretty cool. Here's some, parts and accessories, so we'll just go down through them. The HMI, so you can order that display, and like I said, you can get the blank cover, which is not shown here. I thought it was, but I don't see it. But anyway, there's a blank cover, and you can take that off and put the blank cover on, and then use that. Then here's the whole head, and you can buy just the converter, and it's got a cable connector on it. You can buy the seal adapter, should come with the seal adapter today. You can buy the cable and the counterweight. You can buy the coax in connector, which you guys don't need to know about. Then if you buy the whole process connection, then that gives you the process, the cable, and the counterweight, so it gives you the whole thing. And then down there at the bottom is coax stuff, the tube extensions and everything. But anyway, that's what it looks like, cable and the process connector.